Jai Hind all of you. So welcome to the chemistry class. In today's class, we'll talk about how can that may states of matter interchange or interconversion of states of matter. So before moving to that part, so two questions I can ask you in the last time we have do these questions. Okay, name the process which occurs when a drop of Dettol is added to water. So obviously from the terms we can easily know that when a drop of Dettol is added to the water, the process is known as the process is known as diffusion. The process is known as diffusion. I hope you know very well about the answer. So what is the answer? So the answer is diffusion. The answer is diffusion. If I move into the next question, that to which physical state of matter do the following statement apply? Incompressible, no fixed shape. Obviously, it is meaning that it is a liquid. If it is I talking about the fixed shape, then liquid is there. Compressible, no definite volume. Obviously, we know that whenever I talk about this question, only gas molecule will be the answer. Only gas molecule will be the answer. It's a highly compressible, but it doesn't have the definite volume. So yeah, I hope you got these two questions answer. Now we are moving to the our today's topic. The today's topic start with the question that can matter change its state. So yes, a matter can change its state because we can see that solid can convert to the liquid, liquid can convert to the gaseous molecule. Now how can we change the states of matter? By changing the temperature and the pressure. Now in generally, if I talk about the pressure is the atmospheric pressure, which is generally constant. Again, I am using the uses generally constant. So which factor now is the determining factor to change the states of matter? It's the temperature. So by controlling the temperature, by the changing temperature, we can change the physical states of matter. So one important part you have to know that a gain in heat, or if in the process heat is required, that time the process is known as endothermic change. And if the loss of heat or heat evolution will be there during the process, then that process is known as exothermic process. That process is known as exothermic process. So I hope you got an idea about that what is endothermic process and what is exothermic process, because you have to keep in your mind, and you have to keep in your mind that which one is endothermic and which one is exothermic. Now one just diagrammatically represent I am showing here that when solid molecules convert into the liquid and when liquid convert into the gas, or if I talk about that when solid directly move to the gas without going to the liquid state, what the process is known as, and in which case the heat is evolve and in which case heat is gained. Okay, so first of all, if I have the solid, a beautiful that snowman is there. Now when the temperature will be that when, here very important, the arrow has been given. Okay, arrow has been given there when melting or liquefaction. That means when solid, I am just representing solid as a L and representing liquid as a L. When solid convert into the liquid, that time the process is known as melting, or you can say liquefaction. Okay, so in this case temperature you have to provide it. Sorry, you have to provide the temperature. So with the what is the process, then this process is known as endothermic process. The endothermic process. So I am coming to the point, endothermic and exothermic. So the process is known as melting or liquefaction. If we are doing the same viparient opposite, that opposite phenomena, if we are doing that when liquid convert into the solid, that time this process is known as freezing or solidification. Freezing or solidification. Now if I talk about that liquid to gas molecule, if I talk about that liquid to gas molecule, okay, so when liquid to we are moving to liquid to gas molecules, that time also heat required, and this process is known as evaporation, because in this case vapor forms, vaporizations you can say. Now we see that from the cloud the rain is forming, okay, rain is coming. Now, what actually the process is known is the process is known as a condensation. When gas or vapor convert into the liquid by removing or by losing heat, that process is known as condensation. So as I told, the process is the losing of heat. So this is the exothermic process. So again I am telling that about the exothermic, endothermic we'll talk later. Now one more point is there. If any solid particles directly move to the gaseous molecule, if any solid particles directly move to the gaseous molecule without going to liquid phase, that time the process is known as sublimation. The reverse process, that is the from gas to solid, that process is generally known as deposition, but also we can use the word sublimation for this also. So deposition, the word also we can use. So I hope you can get in a brief idea that which one is a solidification, which one is a liquefaction, or how can we change that any states of matter by changing our temperature. Okay, now here one pattern has been given that when we are changing the temperature, the how it is changing from solid to liquid to gas. If any solid molecule is there and you are continuously heating it, obviously after increasing the temperature it will be converted into the liquid, and similarly if you are giving more heat to the liquid, that liquid also convert into the gaseous molecule. Now if I talk about the reverse process, suppose if gas molecule is there and if you are decreasing the temperature, so what will happen? By decreasing the temperature it will convert into the liquid, and also if I convert decreasing the temperature more for the liquid case, it will convert into the solid molecules. So by this chart you can easily get a understanding that how can solid convert to the liquid or liquid convert to the gas, or vice versa. Okay, so if the question is coming that when gases changes to liquid, whether the temperature is increase or decrease, so you can give the answer yes, it is a decrease, it is not increase. Now the next part, one question is there that ice is a solid, water is a liquid, and vapor is a gas. This is a simple method. It is a simple question. Ice is a solid, water is a liquid, vapor is a gas. What is the explanation behind there? So always remember, if we increase the temperature, ice changes to water, which is a liquid, and on further increase the temperature, water changes to the vapor. So it is just interchanging the states of matter, and that is the explanation of the questions. I hope you understand that how can you give this type of questions answers. Okay, now one example is been given there that how can you see that the conversion of temperature or conversion of states of matter. Suppose you are taking a beaker, in the beaker you are taking some amount of ice cube, and you are just connecting a thermometer, putting a thermometer whose tip is touching with the ice, and you take it the glass stirrer. Now, in the beginning of the experiment, you can see that the temperature should be the 0 degree centigrade of the ice, and that is why it is present as ice. If you just observe the temperature of the thermometer, you can see the temperature will be 0. Okay, now here obviously thermometer shows the 0 value. That time temperature, after giving a little bit heat, the solid convert into the liquid, and that time the temperature also recorded as 0 degree centigrade. Here the temperature also was 0 degree centigrade when the ice was there. Now when you will heat the container through the Bunsen burner is connected here, you can see when the temperature reaches to 100 degree centigrade, it is started boiling. So already you know that before 100 degree centigrade, it will not boil. When you reach the one certain temperature, in the case of the water is 100 degree centigrade, so that in that temperature water boils. So where we are getting the point, freezing temperature or freezing point, boiling point or boiling temperature. So here it is been given the explanation. Okay, before moving to the explanation, we should know about that what is known as fusion, what is known as melting point, what is known as a boiling point and all. So when solid convert into the liquid phase, It is generally the question will be asking that in the case of the solid, intermolecular forces are so strong, intermolecular space are less. Sorry, how can solid changes to the liquid state? So when you are giving heat, when we are giving heat to that ice, what actually happening after taking the heat, the particles will be more energetic. If kinetic energy of the particle increases, now due to increase of the kinetic energy, particle started vibrating with speed. Obviously some way at a one time will be reached. At that time interfollicular forces of attraction will be overcome that by that energy, and you can see that the particles break away and they are forming the liquid states. That point, the temperature at the atmospheric pressure is known as the melting point. So if I asking you that what is the fusion temperature or what is the atomic the melting point, so you can give the question answer like this: the temperature at which solid melts to become liquid at atmospheric pressure is known as melting point. Again I am telling you to mention the atmospheric pressure terms, which is a very important. Here is the question answer has been given there. In the case of the water, the value is the melting point of ice is 0 degree centigrade. Also in the Kelvin scale, it is a 273 Kelvin. In last day, we have seen that how to convert solid to liquid, how to convert that centigrade scale to Kelvin scale. I'm sorry. Now, after melting, another point will come when liquid convert into the boil, that vapor. So that point is known as the boiling temperature, because boiling started when liquid convert into the gaseous molecule, the boiling will be started. Okay. Now, what is the boiling temperature? The temperature at which liquid convert into the gas at atmospheric pressure is known as the boiling point, is known as boiling point. So for the water, we know the value very well, that for water the boiling point is 100 degree centigrade or 373 Kelvin. Okay, so you have to remember this one. One very common phenomena we are observing, that when the steam, obviously steam of vapor, or you can say the steams or water vapor, when you are touching the water vapor, it feels more hot than that the boiling water which has a 100 degree centigrade. What is the reason? Obviously the proper reason we'll read after some time, but you have to remember the reason, that particles in the steam has more energy than the liquid, because when the liquid remove the latent heat of vaporization, then it reaches to the vapor state, and the vapor state, that much of energy extra will be there, and that is why when we are opening the lid of a pressure cooker, we have to remove the pressure, because the steam will be coming as a fire. Okay, and that is a very important, you have to know. So again I am coming to that all the summing up point, that when solid convert to the liquid, that process is known as the melting, and here increasing in temperature is there, here increasing in temperature, so this process is known as the endothermic process. So liquid when moved to the gases, that time also increase in temperature is there, so this process is known as also endothermic process, endothermic process. Now if I talk about the reverse process, if gas convert into the liquid by decreasing in temperature, that process is known as a condensation, and it is called exothermic reaction, because in this case temperature will decrease and heat will be released. Liquid, if we liquid convert into the solid, obviously that time temperature will be decreased, and that is exothermic process. So again we are talking about that the change of gas into liquid is called condensation, the change of liquid into solid is called freezing, and this takes place because of the decrease in temperature. So this part today we have to read. Now one more point is there, that we have to read this part also. Again the already we have summing up this one, that what is called the vaporization, what is called the boiling point, what is called condensation, what is called freezing, and what is called melting. For class 9 purposes specifically I am talking about the examination purposes. The definition is very important, so please read the definition as well. And also you have to understand, if you at first beginning of the this part we have showing a chart. If you remember the chart, you can easily remember. Okay, if I talk about the vaporization, the process of change of water into vapor is called vaporization. For boiling point, if I talk about the temperature in which a liquid boils, it is called boiling point that at atmospheric pressure. Condensation, if I talk about that when gaseous molecule convert into the liquid, that process is known as a condensation. And when I talk about the called freezing, when liquid convert into the solid, the process is known as freezing. If I talk about the melting, when solid convert into the liquid, that time the process is known as melting. So here is the one important the terms which you have to know for the first chapter. So it is the last questions we have to discuss one, that when heat is being supplied to a solid, what does the heat energy of particles of solid? So as I told you that when you are giving a heat to a solid molecule, when you are giving to heat to the solid molecules are generally compact, right? Like compact is there. When you are giving heat, then what will happen? That time the kinetic energy of the particle will increase, and as the kinetic of particle increase, it will be started vibrating. The particle started the vibrating, and obviously as the it is started the vibrating, so one point, one temperature will come. At that point, the force of attraction between the solid particles will break away, and it changes its state to liquid state. So that is the very important question. So I hope you understand this one. So now we can conclude our class for today's. Again we'll meet. Till then, goodbye, take care. Jai Hind.